Hello. So, what we're going to talk about today is the first lesson in our third unit. We're going to be talking about lots of exponent laws. We're going to dip our toes into square roots a little bit, right? But we're going to start here with products and powers of powers, right? So, what we're going to be doing is we're going to be able to simplify different types of expressions where we've got a whole bunch of exponents floating around, right? So, exponents, again, if you don't remember, are the little numbers that are kind of hanging out on the shoulders of other numbers, right? Like if I had something like 3 with a little 2 up there, that means that it's 3 squared, or 3 to the second power, right? So that power, this 2, is called an exponent. All right, so again, we're going to be taking a look at a lot of different ways to handle exponents in different situations. So one of the first things we're going to do is we're just going to take a look at some of these and see if we can come up with a rule about how to handle problems that look like this, where it's something to a power times that thing to a different power, right? So first off, we got z to the 7th times z to the 4th, right? So z to the 7th, right, I'm going to write in red for this one, is basically telling us that I have 7 z's all multiplying each other together, right? So let's go ahead and take a look, right? So 1, 2, 3, 4, 5, 6, 7, right? So 7 z's all multiplying together. After that, right, we've got our multiplication in the middle there, just like it was over on the left. And then we've got z to the 4th as our other piece, right, which again is telling us kind of the same thing, right? It's telling us that I have 4 z's, 1, 2, 3, 4, all multiplying each other there, right? So again, all the stuff in red is z to the 7th, all the stuff in blue is z to the 4th. But if I'm multiplying all of these together, isn't there a better way to write all that, right? I definitely don't want to write it out as all those z's. So let's take a second, let's count up how many z's there are, right? There's 7 in red, there's another 4 in blue. That means that all together I have 11 z's, right? So, just like, z to the 7th said that I had 7 z's multiplying. Z to the 4th said I had 4. If I go ahead, I can write this as z to the 11th. That's telling me that I have 11 z's altogether, right? So, you might be able to kind of pick up on like the little rule here, right? Let's go through another one with these y's on part B. Right, so we've got y to the 6th. We've also got y to the 8th. Right, so y to the 6th, right, is 6 y's. 1, 2, 3, 4, 5, 6. We're then multiplying that by 8 more y's, right? The ones that are underlined in blue. 1, 2, 3, 4, 5, 6, 7, 8. I really should be putting little dots in there, but it does mean the same thing either way. So if I think about how many y's I had total, right, I had 6 plus another 8, right? That's going to give me 14 y's, which I can write as y to the 14th, right? So again, that little exponent number is telling me how many of that thing I have that are all multiplying together, right? So it seems like we might be able to have a little bit of a shortcut here, right? So see if you can think about what would c be? T to the 3rd times t to the 4th times t to the 6th, right? Hopefully what you're coming up with is that we could just write that as t to the 13th. Right? It seems like we can just say, oh yeah, there's 3 there, 4 more there, and 6 more there. All together, that's 13. Right? Same thing for this last one with d. Right? We've got x to the 0 plus times x to the 5th, and then a couple of x squareds at the end there with the 2's. So we had 0, and then 5 more, which is 5, 6, 7, 8, 9 x's. So we write that as x to the 9th. All right, so that's leading us into talking about our product of powers property, which is not super complicated, right? Let's think it through. If I have something like x to the a power, right, and bear with me, there's going to be a lot of variables here, but it's not going to be as scary as it might look. If I have x to the a power, and I then multiply that by x to the b power, right, the way that I'm going to be able to simplify that, and the way that we can kind of think about it in our heads to make it faster, is it's x to the a plus b, whatever those numbers are. Right? So a couple of things to mention here, right? Something important is that it's x in both of these situations, right? I have x to a power times x to a power, and what it spits out is x to that combined power there, right? You need to have that same base number. That's actually what it's called the base. you need to have that same base number or variable or whatever have you in order to use this property, right? If this was x to the a and say y to the b, then this whole other piece falls apart, right? We can't do it quite that way, right? It's not to say that we couldn't multiply them, right? It just doesn't work the way that this property is showing it. Okay, so with that in mind, right, let's take a look at a couple other problems. If we have 3 squared times 3 to the 6th, right, and I wanted to simplify that, again, first thing I'm noticing is that they do have the same base, right? That's 3 to the 2nd, 3 to the 6th, right? So we can use that property. I'm just going to add those powers together. 2 plus 6 is going to give me 3 to the 8th, right? Same kind of deal for example 2 right there, right? If I have negative 6 in parentheses to the 5th power times another negative 6 in parentheses to the 5th power, that negative 6 in parentheses like is the base that they've got in common, right? They both have that exact same thing raised to a power. So again, we're going to be able to, do the same thing. We're going to have that exact base, negative 6 in parentheses, and then add the powers together. 5 plus 5 will give us 10 for that, right? So it can be a little tricky and be like, oh man, it can't just be that, right? Right? But no, that's really all we're doing. And sometimes you might have more than one variable floating around in these types of problems, right? You might have some with r's that also have some s's thrown in, right? So when we're using this property for cases like this, we're combining the ones that go together, right? The ones that have the same base. If I'm looking in the yellow there, actually let's scooch that out of the way. If I'm looking at the yellow highlighted stuff, I had 9 r's and then another 7 r's. Altogether, that's telling me that I have r to the 16th power. Kind of the same thing for the s's, right? I had 5 in the front and then 2 later on, so altogether that's 7 s's. All right? When we're writing out our final answers for these, you might be wondering, like, would it be wrong if I wrote it out exactly like this with that multiplication in the middle? And I'm here to tell you, like, no, it wouldn't be wrong, right? Just normally we wouldn't see that there, right? It's probably a good habit to get into that, if you have 2 variables multiplying each other, you can just stick them right next to each other, right? This problem actually could have just been written from the start as r9, s to the 5th, r to the 7th, s to the 2nd, right? We could have written it out like that. It's just a little iffy to look at as we're learning this, but that's okay, right? But again, if you have variables that are directly next to each other like that, it's assumed that there's some multiplication in between. We just don't write it, right? Take a second, try out that 4th one, right? We've got 2 different variables there. See if you can figure out how many w's and how many k's we're going to end up with. So if you paused and gave that a shot, right? We got some w's, we've got some k's, right? And same deal. I'm just going to kind of run through it. For the w's, we had w to the 4th, and then we had 2 more later on, so that's w to the 6th. As for the k's, when I add up all those powers, I believe I'm going to get 16. Right? So hopefully it doesn't seem super duper bad. Right? Let's talk about another property, right? So if you've got the notes that I handed out, just flip onto the back. If you don't, just keep following along as best you can with whatever you're doing. So we're going to take a look at another property, right? It's going to work. We're going to kind of use the property we just learned about, right? But it's going to run a little differently with problems that are set up like this. So this first one is saying that I have 5 squared to the 4th power. So with the parentheses, it can seem a little strange, right? That 4th power is telling me that I have 4 of that thing multiplying each other. Right? So if I add 4 5 squareds, it'll look something like this. 5 squared times 5 squared times 5 squared times 5 squared. Right? I have 4 of those. So now what I'm noticing is that I can actually use that property we just learned about, right? All of these have the same base. They're all starting with that 5. What I can do is I can add up all those exponents together, right? So 2 plus 2 plus 2 plus 2. Right? When I do that, I'm going to get 5 to the 8th power. Right? And again, you might be able to kind of figure out the little trick we can do to make this a little shorter, right? Let's take a look at the next one just to kind of reinforce what we're doing here. Right? If I have 3 to the 8th power to the 3rd power on the outside of some parentheses, that's just telling me that I have 3 to the 8th 3 times, just like I'm writing out here. right? When I have 3 to the 8th 3 times, right, all the bases are the same. So we can do the same thing, right? We can add together those exponents. So 3 to the 8th times 3 to the 8th times 3 to the 8th. 3/8 will give me 24 there. Right? And again, you might have already noticed that what we can do to shortcut this is we can multiply the exponent on the inside of the parentheses by the exponent on the outside, right? So what I'm trying to say is that when we've got 3 to the 8th, and then that's to the 3rd on the outside, if I multiply that 8 and that 3, that gives me 24. For the one we were looking at a little bit earlier, if I have 5 to the 2nd, and it's all to the 4th on the outside, 2 times 4 gives me that 8 we ended up with, right? So that's actually going to be our shortcut down here for this power of a power property, right? We're going to be saying that if I have, in parentheses, x to the a power, we raise that to the b power on the outside, we can think about it as x to the a times b power, right? So whenever you got parentheses, you can kind of sort of think about it like you're distributing that power to the inside there, right? But when you're distributing a power, it just goes to the other powers, right? We're not doing b times x, we're doing a times b, right? So be a little bit careful with that. So these ones hopefully will seem pretty easy, you know? All we're going to be doing is we're just multiplying the variable on the inside by the variable on the outside, right? So again, here I've got a 2 and I've got a 4. If I multiply those together, I'm going to get that I wind up with x to the 8th power, right? Same kind of deal for x to the 6th to the 5th, right? I've got a 6, I've got a 5. If I multiply 6 times 5, it's going to tell me that I'm going to need x to the 30th power on the outside there, right? Sometimes, and this is going to become more and more common as we learn more of these properties, we're going to be, using a couple different properties at the same time sometimes, right? So here we've got 3m, and then in parentheses, m to the 4th squared, right? So when we're handling something like this, right, again, I said kind of think about it like distributing the power. You only distribute to what's in the parentheses, right? So this squared over here, is only being applied to the piece in the parentheses, right? So that's an important thing to remember. When we handle this, right, we're going to kind of take, we're going to take this 3m and kind of just hold off on it for a moment. All right, so as I go down to a new line of work, I'm just going to write out 3m. I am, however, going to take care of this m to the 4th squared, right? And again, same deal as what we were doing before, right? I'm going to get m to the 8th power, because 4 times 2 will give us that 8. So we got a little bit more to do. Right, we have 3m and then m to the 8th. If I wanted to be really super correct, I would put a little tiny dot for multiplication in there, right? So from here, what I need to do is I need to figure out how to multiply these things together, right? And if you remember anything about combining like terms, right, you're smushing together the pieces that, match up and go together. That's kind of what we're doing here, right? If I have 3m times m to the 8th, the m's multiply each other, right? There's a couple different things that we can add here to kind of illustrate what we're doing, which, you won't often see, but if it helps you and you want to write them out for yourself, go for it, right? So I know you don't have the power to just like scoot your writing over like that, but, right, if I have m to the 8th, then that is just telling me that I have a single m to the 8th, right? 1 m to the 8th is what I've got. Over on the left side, if I've got 3m, right, that m still has a power on it that we just don't see. It's an invisible 1 there as well. Right, so this is 3m to the 1st times 1m to the 8th. Right? When I'm multiplying these, right, I mentioned, combining like terms a second ago. It's sort of similar. The 3 multiplies with the 1, right? The numbers multiply together. So that's still going to wind me up with 3. Then the m's multiply together. If I have m to the 1st times 8 more m's total, that's going to give me m to the 9th power, right? So, if you're seeing a problem and it doesn't have that 1 above the m where I just erased it, right, don't forget that it is supposed to be there. There is a single m that you're multiplying by, right? So that does combine with the other 8 and give you that m to the 9th. Right, so be a little careful on that. Once we get to here, right, this is what we wanted. 3m to the 9th. Oops, oh goodness. Let's try that again. Let's try making a box instead. Oh, we tried. Well, 3m to the 9th is what we want as our final answer there. All right. What I'd like you to do is pause here, try out that next one, for example, 8. Right? It's kind of similar. If you need to go back and rewatch what we just did, go for it. So hopefully you paused and gave that a shot. If not, give it a go. It's not going to hurt, I promise. Let's talk through it together a little bit. If I've got 2g times, in parentheses, g to the 3rd to the 9th, right, we're going to approach it pretty much the same way. Right? So again, I'm going to take 2g, I'm just going to kind of bring it down. And what we're multiplying it by is whatever we get with all that parenthesis nonsense. We've got g to the 3rd to the 9th. I'm going to use my property that says I can multiply those highlighted blue things together. It's going to give me g to the 27th power. Right? We're going to add a couple more things, which again, just like on the last one, we won't normally see those ones in there, right? Just like we don't necessarily need to write them in here, but they do still exist. Right? And again, if it's helpful to write them in, go for it. Right? So we've got 2g to the 1st power, right? There was a single g there, times 1g to the 27th. Right? So just like before, the 2 and the 1 multiply. It's going to give us 2. The g to the 1st and the g to the 27th multiply. It's going to give me g to the 28th power. Right? So 2g to the 28th, that's what we're going for. Right? And I know that you got a little bit of an activity further down the page. That's something that we're going to take care of possibly during class next time I see you, because it's a little bit easier to do in person, right? So that's actually it for now. A bit of a short one. I hope that's okay. And be sure to ask questions if you have any on this. And I will talk to you next time. Peace out.